Hi, welcome to my channel if you're a new viewer, and welcome back if you're an existing subscriber. Today I'd like to talk about setting up Modbus TCP communications. This will be done within Codesys, also known as UOS within the Weidmuller world. We're going to use Codesys to set up the PLC controller as a client, and we're going to be talking to a Weidmuller UR20 Remote I island, which looks very much like this product on the right at the top of the screen. The principle would be the same whether you're talking to a variable speed drive, a soft start, a third-party remote I/O island, any product that supports Modbus TCP. Could be an energy meter, for example. Okay, so let's jump in straight away and go to Codesys. So I'm going to start with a totally blank project. So we go to File, New Project. I'm going to use a standard project, and I'm just going to call it WL2000 Modbus TCP Test. Okay, there we go. So if you look in here, you can see all the various hardwares available in the Codesys environment. There's a lot more than that. So this is what comes with Codesys, and these are the Weidmuller products I've added. So I will pick the WL2000. But just to say, this application, which is Modbus TCP, could equally be on a Raspberry Pi or another third-party device, because Codesys is a fairly open platform and there's lots of hardware that could be programmed using Codesys. And you see down here, the bottom of the screen, building relationships. It's building up the project in the background, a basic project. That takes a minute or so. Okay, and then it creates your device tree. So the name of the project, the device, and your basic structure. So the first thing I need to do is add an Ethernet connection. So we go into device, right click, add device, and pick Ethernet adapter here, and add device. Close that. Now click on the actual Ethernet device, right click and add device, and now we add a Modbus TCP master or client. Add that. Click onto the actual client, and now add new device. And now we pick Modbus TCP slave or a server. So if you're not familiar with the terminology, server, simple way of thinking about it is it's serving up the information. You're giving inputs back into the controller, but you're also taking outputs from the PLC as well. But it is a slave or a server, because the PLC is the intelligence telling the server what to do. Okay, so close that. And then we have a basic structure here. Add device, Modbus TCP server, add device. Just expand that a bit better. So you've got an Ethernet connection, we've got a Modbus TCP client, meaning the controller itself, and a Modbus TCP slave. If you want to, you can rename that. Just right click on it and say refactoring or rename, and then you can call it, for example, UR20 Remote I/O, or variable speed drive or soft start, or whatever you're talking to. Okay, but I'll leave it alone. Then we need to configure some other elements. Probably a good idea to actually make sure your controller is up and running, because some of this you actually want to be online to the controller to configure. So let's look at that now. And the login will be whatever you've defined, because when you buy the controller, doesn't have any security setup, you have to log in and create a user. So your login will be different to mine. So we log in, and then I like to go into the UOS control center, apps, app manager, and the key thing is I just want to make sure Codesys control SL, which is basically the Codesys runtime that lives on the controller, is working, up and running. Okay, and it is. So if I go back to Codesys now, we can double click in here and we set up the communication. So you're normally using gateway 1, and in here you type the IP address of the device you want to connect to. My username, my password, okay that. and hopefully it will detect the device. There we go. Green lights on the gateway, green lights on the PLC, and it now says active connection. So what I'd suggest we do now is go into the Modbus TCP server, and in here you define what registers you want to communicate to in the slave or server device. So I'm using a Weidmuller UR20 Remote I system, so let me show you the mapping of the registers within that device. What we have here is a view of the U-Remote I system, and it's made up of 5 elements here. Item 0 is what we call the field bus coupler, so it's a UR20 FBC field bus coupler Modbus, okay, and that's its MAC address. And then in slot number 1, an add-on module, we've got a 16 digital output module with positive switching, PNP switching, and their transistor outputs, and it uses holding register 2048, or in the old Modicon Modbus register system it's a 4X register 42049, if that means more to you than that address, okay. And then in slot 2 we have 4 DIP, so 4 digital input with positive PNP switching again, and that's holding register 0, because on the Weidmuller UR20 all input registers start at address 0 and all outputs start at address 2048. This is explained more in the manual, but you might not be using a UR20, this is just an example anyway. So in slot 3 I've got another digital input module, and it's a UR20 16 DIP, so 16 digital inputs, PNP switching, and that's using the next input register, address 1. And the 4th module I haven't got, it's like an extension module, I haven't got it connected, therefore I've got a red light, and we're just not going to read or write to that, it's not really relevant. So that's the addresses we need to read and write to, so we now got to configure that information within inside Codesys, so let's do that. Okay, so we're in this view, Modbus TCP server. So here we need to set up channels. Add channel here, call it channel 0, and then we decide what Modbus function code we want to read. So Modbus TCP or Modbus RTU serial comms, or Modbus comms uses Modbus function codes. So I'm going to use a Modbus function code 23, which means I want to read and write multiple registers. So I'll click on there, and I'm going to put a comment, communication to Weidmuller UR20 remote system. So offset, the register you want to read from, the offset is basically the first register you want to read from. Now I want to read from address 0, and if you remember we're reading 2 registers, so I change that length to 2. Then we want to write to 1 register, and if you remember it was register 2048. So in here I just type 2048, and I've only got 1 output card, so I only need to write a length of 1. So I hit OK, and this generates this information, and it's saying I'm reading register 160248 and reading from register 0. Right, I have made a little mistake here, so let me just explain. So I'm reading from register 0, which is correct, and I'm reading 2 registers, register 0 and register 1. But here, the right offset, it says I'm writing to a hexadecimal register number 2048. The register address is actually 2048 in decimal, so what I do is click in here, and if I just put 2048, and then if you hit OK and you look up here now, it's changed to a hexadecimal number 0800. So it's a little bit strange in the Codesys world. They've put 16 hash here, but in this screen they just put 0x, but that is hexadecimal format. So I hope that makes sense to you. So I'm reading register 0 in decimal, I'm reading register 2048 in decimal, which equates to hexadecimal value 0800. And if I just move that across, I'm just writing one register. So I like to call this an I/O scanner because it's just a configuration. So we've defined registers we want to read and write, and they're going to be cyclically scanned and updated. This is a lot easier than having to write application code to do Modbus comms. This is really straightforward. What these other elements are here. So if I go to Modbus Server initialize, in here I can add a new basically channel in the same way, and here I can set initial values for registers. So I can, I don't know, set an initial value for the configuration of an analog channel, and I can point to an address, say register 1, and load an initial value. I'm not going to use that. Let's just keep it simple, but that's what that would do. Modbus TCP server parameters. So this gives you access to the server device where we can change parameters. So first thing we need to adjust here is the IP address of the server device we want to talk to. So let me just remind myself what IP address I'm using. 1.223. And you've got a unit ID, and the unit ID is 255 at the minute. So I'll just explain that with Modbus TCP comms, a unit ID defines if you're speaking directly to a Modbus TCP device, in which case this number would normally be 255 or possibly 0. The only way to know, to be sure, is to read the documentation of the slave device you're using. And this is the response timeout, so it's 1000 milliseconds is the maximum time I'll wait for a response before it sees that as an error. Just going back to the unit ID, sometimes you have, for example, an Ethernet Modbus to Modbus serial gateway, in which case the unit ID will be the ID on the other side of the gateway. For example, if you've got 5 energy meters, they might have their own Modbus serial addresses 1, 2, 3, 4, 5. So in here, if you wanted to speak to the first meter, you'd replace that with a 1, second meter a 2, etc. That's how it works. Okay, Modbus TCP server I/O mapping is basically the internal registers, the data you're reading and writing from the server is either read from or put into. So for example, here IW0 is reading the values read from the first digital input card. So they're coming in to the PLC and they come into register IW0, and from the second card they come into IW1. And if you notice, you can expand them and they are at bit level. So because it's one card was a 4 channel using 4 bits, so it will be these 4 bits, and the other channel was 16 bits, so it would be using 0 to 1.7. That's 16 bits there. Okay, and here, when I want to send a value to the outputs, this is the register I'd write to, QW0. So for example, if I wrote to actually QX0.0, if I wrote a 1 into that register, I'd be turning the first digital output on of the 16-way output card. I hope that makes sense. And then status, when you're online, you'll get some status information here and possible error messages. So what I would do now is go back to device, check I'm online, and I am, I've got an active path. Go into client, probably tick auto reconnect is a good idea. So in other words, if you lose a connection, for example, the cable gets pulled out, reinserted, it reconnects. And again, you've got a 1 second timeout here on this communications. I normally leave that alone, use parent bus cycle settings. Go to Ethernet. I know I need to bind the Ethernet communications to a particular port on the controller. The controller I'm using, the WL2000, has 2 Ethernet ports, X1 and X2. So if I click browse, it connects to the device. You notice now that's got a connection, and it gives me Ethernet 0 or Ethernet 1. So Ethernet 0 I'm using to talk to the public internet. Ethernet 1 I'm using to talk to my local area network on my machine, for example. So that's what I want. OK that, and notice it changes the IP address. So that's that part done. So really, I think we can now go online and see if we can read and write to the remote I/O system. So I'm now going to go online to the controller, log in. I haven't actually done a build yet, so it's saying there is an application on the controller. It's in run. Do you want to stop it? Yes, and download the new code. So it's generating my code. If you look down here, percentage downloaded, and hopefully we'll see some green lights here. So we've got a red warning triangle at the moment, but we are in stop. So if I put the controller into run, okay. So if you can see now, applications running, we got the run down here as well. Programs loaded, everything looks happy. If you look here, 0 errors, 0 warnings, good news. I've got a green light on the main task, although in reality there's no task there. There's no application code I've written yet, and I'm getting orange indication here, and that's because I don't have a Codesys runtime license on the controller, so it's saying I'm running in a demo mode. Okay, and I've got a red warning light on my system bus, and that's because I haven't configured any system bus. System bus is the local I/O on the controller. There isn't any setup, so don't worry about that. So if I go to Modbus TCP Client, Server, and go to I/O mapping, let's see if I'm reading any data. So I'm not reading any data. Let's have a look here. It says not updating, check tooltip. So if I just hover my mouse over there, value is not being updated because it is not used in the code, nor the settings always update variables is enabled. Okay, so that is quite right. I don't have any application code to read these registers. Okay, so what I need to do is go to here, always update variables. So I'm not using any application code. I'm trying to keep this as simple as possible. So what I need to do to change that setting is to take the controller offline, log out, enable one, use bus cycle task if not used in any task. So in simple terms, that just means the I/O will now update without actually being in an application, any application code. Log in with online change. I've rearranged my screens now so that I can actually look at the internal web server, the U remote, and look at the PLC program live values. So both are showing live values, and if you notice, the first input channel, the first channel of that card is on, so bit 0 of that 16-bit word is on. So if I look in the PLC, just expand that a bit, there you go, I'm seeing a value 1 of the word, and I'm seeing a true, meaning that bit is on. So the first bit is on, that's correct, so that's good news. I have got this digital output card hardwired to the digital input card, so if I turn some outputs on, we should see them come on, and we should see the input come on as well. So let's try that. So if I go down to the array of outputs, and if I turn on, let's just make that a bit better fit to the screen. There we go. So if I turn that output on, Control F7 to write that value. There you go. That output has come on. Let's try the second one. Control F7. Output has come on, and I've got it hardwired to that input. So that input's come on. So if I look into first input card, I now get a value 3 in there because the binary weight, so that's worth a value 1, isn't it? The first bit's value 1, second bit's value 2, second bit's value 4. So let's turn on another output. Okay, so that one's turned on. Yeah, and it's hardwired to that. So if we look at the first channel again, the first input 1's on, 2 and 3, because it's just a 4-channel card, yeah. So 1, 2 and 3 are on. So there you go, we're reading and writing data over Modbus TCP from Codesys to a U remote. And as I say, that I'm using a U remote, but you could be using a variable speed drive, soft start, whatever it might be. Okay, so I appreciate that was a bit of a long video, but hopefully it will help you because it was all done in real time. And I hope that will be helpful for you in the future. Please like and subscribe, and hope to see you on the next video. Thanks for watching.